Good day, everyone. So, this video presents the topics in geometry. Okay. So, our first topic is about polygon. So, polygon is derived from two Greek words, poly meaning many and gonia meaning angle. So, a polygon is a closed plane figure bounded by line segments as the sides and with three or more angles. So there are as many sides as many angles. Na? So let us say if we have 5 sides, we have also 5 angles. Na? So the number of sides also equal to the number of angles. Okay. So a polygon can be irregular wherein the length of the sides are unequal and also not all the angles are equal. Na? Then we have regular in which all the sides are equal and all the angles are also equal. Okay. So, polygons are named according to the number of sides that they have. So, the following names of polygons are listed below. So, we have that here. So, familiarize the names because sometimes the question involves the name of the polygon and you're the one to determine how many sides are there in that polygon. Okay. So, properties of polygons. So, number one, we have here, if we are given a polygon, we have an interior angle. Huh? So, A here or alpha is an interior angle. So, we have also interior angle at B, at C, and so on. Na? So again, there are as many angles as many sides. Then we have also an exterior angle. So let us say we have here angle beta. So an exterior angle is defined as the angle between one side and the prolongation of the other side. And that is measured outside the polygon. Then we have diagonal. So, the diagonal is the line segment connecting two non-adjacent vertices. So, we have that here. Huh? So, an interior angle is the angle inside the polygon bounded by two adjacent sides, as in angle alpha. Now, the sum of the interior angles, so S subscript I, no? So that is given by the formula n minus 2 times 180 degrees, where n is the number of sides. So we have also an exterior angle. We define again. Exterior angle is the angle outside the polygon bounded by a side and the prolongation of the adjacent side. As in angle alpha in our figure there. So, the sum of the exterior angle is fixed at 360 degrees. So, there is no formula here because we have a fixed value for the sum of the exterior angle. That is equal to 360 degrees. Then, a diagonal, as we defined earlier, that is a line segment connecting two non-adjacent vertices. So, kindly correct, no? A line segment connecting two non-adjacent vertices. So, kindly place none. So, two non-adjacent vertices. So, we have here. So, the number of diagonals is equal to n over 2 times n minus 3, where n is the number of sides. Okay. We have also circumscribed circle. So, when you say circumscribed circle, that is a circle drawn which touches all the vertices of a regular polygon. And the radius of the circle is the distance from any vertex to the center. So we have here, no? So if we have a regular polygon, then we can draw a circumscribed circle. And the distance from the center to any vertex is what we call the radius, or is the measure of the radius of the circumscribed circle. We have also inscribed circle. So, an inscribed circle is a circle drawn inside a regular polygon which is tangent to all the sides. And the radius of the circle is the perpendicular distance, no, from any side to the center. and we term it as the apothem of the polygon. Okay, so apothem of the polygon is the radius of the inscribed circle of a regular polygon. So we have here an inscribed circle, then we have here the radius, and this is what we call the apothem. Okay, so we have here problem. So number 1, we have here, how many sides does a polygon have? Now, how many sides has a polygon? If the sum of the interior angles equals twice the sum of its exterior angles. Okay, so this problem involves the sum of the interior angles and the sum of the exterior angles. So we can use the formula. So if n is the number of sides, so the sum of the interior angles is n minus 2 times 180 on the left side, and equal to twice the sum of the exterior angles, and the sum of the exterior angles is 360 degrees. So we can cancel out, no? 360 divided by 180 is 2 times 2 is 4. Then we can solve for n, that is equal to 6. So there are 6 sides of the polygon. Number 2. How many sides are there in a polygon with 54 diagonals? So, if there are 54 diagonals, then how many number of sides are there? Okay. So, solution, we can make use of the formula for the diagonal. Formula of the diagonal in terms of the number of sides. So, n over 2 times n minus 3. So, number of diagonals equal to 54. Then we can solve for our n. So, by quadratic, we come up with 12 and negative 9. Of course, the applicable value there is 12. Problem 3. ABCD is a square of sides 10 cm. 4 congruent isosceles triangles with sides equal to x are cut from the 4 corners so that the remaining portion forms a regular octagon. Compute the area of the octagon. Okay, so we have a square of sides 10 cm, and then we will cut from each corner 4 congruent, no? So 1 for each corner. 4 congruent isosceles triangles with sides equal to x. And the remaining portion there is a regular octagon. Compute the area of the octagon. Okay, so we have that here, no? So if this is our square with sides 10 cm, 10 cm, then we will cut a triangle at each corner. So these are isosceles triangles of sides x. Then, the remaining portion, after you cut these triangles, we have a regular octagon. So what is the area of the octagon? Okay. So, xx, this is xx. So we have here, the total length here is 10. So this length here is 10 minus 2x. So 10 minus 2x. Now, from the triangle, if this is x, this is x, this is square root of 2x. And notice, these are sides of the regular octagon. So meaning, this side and this side are equal. So we can equate the two expressions. So square root of 2x, that is equal to 10 minus 2x. And from that, we can solve for x. So, if we have the value of x, then we have the value of the sides of the octagon. So either we use 10 minus 2x or square root of 2x, we have the same result. Okay, so I will just use 10 minus 2x. So the length of the side is 4.14. So I will now cut the octagon here. So what is the area of that octagon? So when we are asked for the area of a regular polygon, so the idea there, the strategy is to slice it into equal triangles. And then consider one triangle, solve for the area of that triangle. And the area of the regular polygon is equal to the area of the triangle times the number of triangles formed when we cut the regular polygon. Okay, so we have that here, no? So let us say we cut it into triangular parts. So of course, we have 8 equal triangles because we have a regular octagon. So I will consider one triangle. So this triangle here. So this side is 4.14. And since this is 10, from the center, perpendicular to the side, or what we call the apothem, this is equal to 5. So I can solve for the area of one triangle and then just multiply it by 8. So the area of the octagon is equal to 8 times the area of the triangle. Then we have the answer. 82.8. Okay. So next topic, we have triangles. So a triangle, although in trigonometry we have discussed already triangle, but that is about the relationship of the parts and the application. Now here in geometry, our discussion on triangles still involve the relationship of the parts, but mostly we have the properties and the computation of the area. So we're here. A triangle is a three-sided polygon, and we know we have 6 parts. The 3 sides denoted by A, B, and C, small letters, and the 3 interior angles represented by big letters A, B, and C. So we have that here. So what are the formulas in the computation of the area of the triangle? So it depends on the given. So the first formula, which is the general formula, that is the area of a triangle is equal to 1/2 the product of the base and the altitude to that side. So if we know one side, which we call it a base, and then we know the altitude or the perpendicular distance from the vertex, opposite vertex to that side, then we call it the altitude. So as in the figure, So the side B here can be taken as a base, and then we have here the altitude to that base H. So the area of the triangle is equal to 1/2 base times the altitude. Okay, so number 2, we have area of a right triangle. So of course, when we have a right triangle, the 2 perpendicular sides, which are called the legs, so we have there one base or one side can be taken as a base, the other is the altitude. So in that case, in the figure, area is equal to 1/2 A times B. Okay? Third, we have, if we are given 2 sides and included angle of the triangle. So let us say we have that here. So we are given here 2 sides and the angle included in between the 2 sides. So the area of a triangle is equal to 1/2 the product of the 2 given sides and the sine of their included angle. Now take note, angle is the included, angle between the 2 sides. If in case we are given another angle which is not the included between the 2 sides, of course, we cannot use this formula. So applicable only, again, if we are given 2 sides and the included angle. And the included angle is the angle in between the 2 given sides. So area is equal to 1/2 the product of the 2 given sides AB and the sine of the included angle theta. Okay, so fourth formula, if you are given 2 angles and any side. So let us say we are given 2 angles and then any side of the triangle. So let us say we have here, so we are given angle A and angle B, and we have here, let us say, side B. But this can be any side. Now take note that we can solve for the third angle, C. So as if we know already the three angles, and then we have one side. So the area of the triangle can be computed. Area is equal to the square of the given side times the sine of angle A, sine of angle C, divided by the sine of B. Now, what is to be noted in this formula? So, take note that if you are given side B, the opposite angle, which is angle B, should be in the denominator. So, B squared, then this is sine of B. Then you have a factor 2 in the denominator. So, the remaining two angles, the sine of those angles are placed above. Okay. So, meaning, if we are given A, side A, so this becomes area equal to A squared, then the denominator is 2 sine A. And we have here sine B, sine C. Then lastly, if we are given side C, for example, so this becomes C squared, then the denominator is 2 sine angle C. Then the sine of the two angles are placed above the fraction. Okay. Number 5. If we are given three sides, so if we are given three sides, we can use the Heron's formula. So let us say we are given the three sides A, B, and C. And the Heron's formula can be computed using this formula. So square root of S times S minus A times S minus B times S minus C. Where what is S? We call it the semi-perimeter, and that is A plus B plus C over 2. Okay, so kindly take note of those formulas. So when we solve now problems, any of those formulas can be used in order to answer the area of the polygon. So to illustrate, we have here number 1. A triangular field has sides of lengths 125 yards, 160 yards, and 225 yards. Approximate the number of acres in the field, in which 1 acre is equivalent to 4,840 square yards. Okay. So, what have you noticed? We are given here the three sides of the triangular field. 125, 160, and 225. So, from this, in order to solve for the area of the triangular field, since we are given three sides, we can apply the Heron's formula. So, applying the Heron's formula, so S equal to the semi-perimeter. So, by substitution, we can get the semi-perimeter 255. Then we can solve for the area using the formula. Then, nandiyan na yan lahat, no? All the values needed in order to solve for the area are there already. So, by direct substitution, we can get 9,720 square yards. But the answer should be expressed in acre. So, we will convert. So, multiply this by the conversion factor, 4,840 square yards equal to 1 acre. And the answer is equal to 2. Okay, so that illustrates the use and how to compute the area using the Heron's formula, if we are given three sides. Next problem. Problem 2. The sides of a triangle are 45 meters and 55 meters. If its area is 785.48 square meters, find the sum of the sides. Okay. So, we are given a triangle with two given sides, 45 and 55. And we are given the area. And the question is, find the sum of the three sides. So, we are given already two sides. We lack one side, this side. So, if we can solve for this side, then we can easily sum up to solve for the requirement. So we have here. So recall that if we are given two sides and included angle, we can solve for the area of the triangle. So for the given here, since we are given the area and then we do not know this included angle between the two sides 45 and 55, so it is being reversed. So using the formula with the area and the two sides, then we can solve for the angle theta. Okay? So if we substitute, area is 785.48, 1 half 45 times 55, sine of the angle theta. And the angle theta can be solved 39.40. So after we have that, we know two sides and included angle, we can solve for this third side. I will call it x by cosine law. So by cosine law, x squared is equal to 45 squared plus 55 squared minus 2 times 45 times 55 cosine of 39.4. And then I can solve for x. So, the perimeter, which is the sum of the three sides, is equal to 45 plus 55 plus 35. And the answer is equal to 155. Okay? So, problem 3. A triangle has two known sides, namely AB equal to 40, AC equal to 60. Point D is on line AB such that AD is equal to 25 meters. Point E is on the line AC such that the area ADE is 1/3 of area ABC. How far is E from A? Okay. So, we already discussed that in trigonometry. Trigonometry problems and geometry problems are similar, no? The same. So we are given a worded problem and then we have to draw it, no? So we must understand what we are reading and then draw the correct figure out of the worded problems that we read, no? And then analyze how to solve for the problem. Okay. So, given a triangle, so the triangle has sides AB, AC, and BC, na? So, triangle, two sides AB and AC. Of course, the third side here, na? AB, AC. So, the third side is BC. Anong side yung BC? Okay? So, we can draw it. So, AB is 40. Then, AC equal to 60. Okay. Point D is on line AB. So, point A is on line AB such that AD is equal to 25. Nandito yung 25. Point E is on line AC. So, point E is on line AC such that the area ADE is 1/3 of the area ABC. How far is E from A? Ayun. Okay? So, we have viewed already the problem situation. So, we will now analyze how to answer the question. So, the question here is the distance AE, no? How far is E from A? So, we will call it X. So, given that area ADE is 1/3 of area ABC. So, area ADE is 1/3 of area ABC. So, we can substitute. Now, for this formula, for the formula to be used here, I will use two sides and included angle, although we do not know angle theta. We will just see the result. No? So, ADA, so 1/2 25 times x, sine of theta. So, 1/2 25 times x sine theta, Then, area ABC, 1 half 40 times 60 sine of theta. And area ADE is 1/3 to area ABC. Okay. So, as you notice, sine theta will simply cancels out on both sides. And we are left here with x as the unknown. Okay? So, 48. Next problem we have here. A line is drawn from P to Q. A line is drawn from P to Q, where P is a long line AB. So we have here line AB, then there is a point P, and Q is a long line AC. So we have line AC, and then along that line we have point Q. So dapat what we need here is to note the given positions of the point so that when we draw it, we can easily locate the points. So P on line AB, Q on line AC of the triangular lot ABC. Okay, so we can draw that sentence. So P, Q. So a line is drawn from P to Q. So we have drawn that already, Okay, so we have here AP is to PB. So the ratio of the length AP is to PB is 3 is to 1. And the ratio AQ is to QC is 2 is to 5. What is the proportion of the area APQ over area ABC? Okay. So the question is the ratio of the area APQ over the area ABC. So since we are given proportions, now we do not know the actual length of the sides or of the measurements. But if we will just take one unit for the proportion, so for every proportion here ratio, I will just take one unit of each. So if I have AP over PB in the ratio 3 is to 3, 3 is to 1 I mean. So AP is to PB in the ratio 3 is to 1. So I can say that the distance is AP. The distance AP is 3 units. And the distance PB as 1 unit. So, will you agree? So, AP over PB, that is equal to 3 is to 1. So, I will do the same for AQC. So, AQ is to QC is to 2 is to 5. So, meaning, AQ is 2 units and QC is 5 units. So, considering that, so the total number of units from A to B is 4. And the total number of units from A to C is 7. So I can now compare the area or take the ratio of the area. Okay. So I will call angle theta the interior angle between AB and AC. So area area APQ is 1/2 3 times 2 sine of theta. So that is 3 sine theta. I have also area ABC. So that is 1/2 4 times 7 sine of theta. So that is 14 sine theta. So what is the question? The area APQ divided by area ABC. So we will simply take the ratio of the two results here. So area APQ over area ABC is 3 sine theta over 14 sine theta. So sine theta cancels out and the answer is 3 is to 14. Okay. Next we have here the vertex of an isosceles triangle is 30 degrees. And the side opposite the vertex is equal to 40. Find the area of the triangle. Okay. So, if we have here an isosceles triangle, we call this the vertex angle. And opposite the vertex angle is the base. And these two equal sides are called the base angles. So, okay ba yan? vertex angle, opposite is the base, the side which is the base. These are called the legs. The two equal sides are called the legs of the isosceles triangle. And these two angles are called the base angles. Okay. So the vertex of an isosceles triangle is 30 degrees. And the side opposite, which is the base, is 40. Find the area of the triangle. Okay. So since we have equilateral or isosceles triangles, these two angles are equal. So the sum is 180. So if this is 30, so the sum of the two here is 150. Nah? So 180 minus 30, so we have here 150 for these two angles. And since they are equal, then each measures 75 degrees. Okay? So for this triangle, we know all the angles and we know one side. And we can use the formula for the area in which we are given one side and the three angles. So we are given B, so the denominator is sine B, the opposite. Okay, so substituting values, all the angles and the side given are there already. So we can solve for the area, 149.82 degrees. Okay, so that video is about the polygons, and then we have area of triangles. No? So next video will follow. No? So I am setting my video discussion for about 30 minutes. No? Because it's boring to watch a longer video. No? 30 minutes maximum. Okay. So thank you, and then wait for the next video or just open the other videos there. Nah? So you can open what you want or what topic you need to know or to learn. Okay, so thank you very much.